Okay, deformation of solids is changing shape and or size of an object is called deforming the object. Some objects are easy to deform. We call them soft objects. Some objects are difficult to deform. Such objects are called hard objects. Now, what is elasticity?
How much you can stretch something?
No, that would be softness or hardness of an object. Like, no,
To bend?
elasticity. No. Uh, when we deform something, some of the objects have ability to come back to their original shape and size, and and some object cannot come back to the original shape and size. Some objects they can come back to the original shape. Like we bend them, they get bent. We let them go, they come back to the original shape. We stretch them, they get stretched. We let them go, they come back to the original shape inside. We compress something, it gets compressed. We let it go. Sometimes it takes time, sometimes it immediately comes back to the original shape and size. Such objects are called elastic objects. The objects that cannot come back are non-elastic objects, or we call them plastic objects. So what will be elasticity? Ability of an object to regain its original shape and size when deforming force is removed. Like what this sentence is trying to say, that when we apply a deforming force, it can change the shape of an object, but when we let it go, it comes back to the original shape and size. Now, how many different ways we can change shape of an object? No. Here we have 4 objects. Okay, can we do this? Like, for example, this is object A, and if I engage it with outward forces like this and this, what would you call it? Like what has happened to A? A has been stretched. It's called stretched. Now, what about this one? If there's a force inwards and there's a force inwards as well, what will happen to this object? It will get compressed. That is another kind of deformation. Okay, if I engage three forces, or if I engage this object with three forces, there's a possibility I can do this. I can engage a force like this, another force like this, and a third force like this. What did I do over here? This object is being bent. Okay, now in this case, so what does this look like? What did we do over here? This object is being twisted. Now, I can deform an object in all these ways. But when I let go of them, if they go back to their original shape, they are elastic. But if they don't go back to their original shape, they are inelastic or plastic. When deforming force is removed, like deformed, and now deforming force is removed, as all objects returned to their original shape and size. So all objects A, B, C, and D are elastic. Now, what is elastic limit?
So
Even
is it like the max that it can stretch and come back to its original form? And after that, after you reach it, it doesn't come back to its original form?
perfect, perfect. It is exactly that. Even the elastic objects, they are not elastic, excuse me, they are not elastic for all values of forces and extensions. They, even the elastic objects, they are elastic for a certain range, and beyond a certain force, they are no more elastic. For example, if there is a spring, we stretch it, it comes back to the original shape and size. We stretch it more, it again comes back to the original shape and size. But then we like stretch it to a very large value, and we let it go. It goes back, but could not go back to the original shape and size. There was some permanent deformation in that object. So it means that we have stretched that spring beyond its elastic limit. Now, maximum load that an elastic object can take without getting permanently deformed. Beyond elastic limit, even elastic objects are no more elastic and get permanently reshaped or desized. Just 1 second. Okay, now elastic objects are elastic to a certain value. If we stretch them or engage them with a force beyond the elastic limit, they start to get permanently deformed, and this is called elastic limit. Now, Hooke's law. What is Hooke's law? Hooke said deforming force and extension are directly proportional. Deforming force and extension are directly proportional within within elastic limit of stretched object. Now, force is directly proportional to extension. Now, what is force and what is extension? This is very important to understand. This is an object, and when I engage it with forces, it gets enlarged. Okay. This is when I engage this object with a force there and a force there. Equal and opposite forces are acting on both ends. This is force F. This is force F. This is original length of the object. Let's call it L naught. This is stretched length of the object. Let's call it L. Now, every symbol has to be explained. L naught is original or unstretched length. L is stretched length. F is deforming force. E is extension. Remember, E is not the stretch length, E is extension. E equals to stretch length minus original length. Extension equals to stretched length minus original length. So Hooke's law says deforming force is directly proportional to extension. Like if you exert more force, there will be more extension. Not only that, if you increase the force, the extension will increase in the same ratio. For example, if you increase the force to double, extension should be doubled. If you increase the force to 4 times, extension become 4 times. If you reduce the force to half, extension become half. This is what directly proportional means. It is not like if one increases, the other also increase. That will be a positive correlation. To be directly proportional, both of the quantities should change in the same ratio. Now, force is directly proportional to E. So force equals to KE, where K is spring constant. K equals to force over extension. Within elastic limit, force over extension is a constant. So if we have a force 1 and extension 1, then we have force 2 extension 2, then we have force 3 extension 3, and so on. We have force number n and corresponding extension number n. If all of them are within elastic limit, in all cases, you are supposed to get same answer. All of them will have same ratio. This is what is meant by uh, two quantities being directly proportional. If they are directly proportional, at any point, their ratio has to be exactly same. Now, how can we plot this thing on a graph? Okay, this is now how the graph of force and extension and stretch length and extension will look like. Now, this is now this is extension and force. This is length of spring and force. So this is how the graph should look like for extension. And this is how the graph should look like for length. Okay. Now, what's the difference? Force and extension graph starts from origin, but force and length graph does not start from origin, because when there will be no force, extension will be zero, but that does not mean the length of the spring will become zero. Look over this, look over this graph. What happens when there is no force acting? Even then there is some extension. That means that this is unstretched length, because this is the point when there is no force, and the length of the spring or wire or anything that we are stretching, it can be rubber band or any elastic cord that we are stretching. And if it is a length and force graph, the y-intercept will be the unstretched length of the spring. Now, let's make some more graphs. Mhm. Okay. This is force, and this is extension. This is force extension graph. Remember, for force extension graph within elastic limit, for force extension graph within elastic limit, gradient of graph is equal to spring constant and area under the graph is elastic potential energy or strain energy. Examiner won't ask you to find strain energy or elastic potential energy. Examiner can ask you to explain what strain energy or elastic potential energy is, but at your level, it is not in your syllabus for finding elastic potential energy from the graph. Okay, but it is very simple. I don't know why it is not there. Just find area under the graph, and that will be equal to strain energy. Force extension graph beyond elastic. For example, if we stretch something and we take it beyond elastic limit, what will happen? So this is a straight line. Yeah. So what will happen if I go beyond elastic? Let's say this is elastic limit. This is elastic limit. And Hooke's law said force and extension are only directly proportional to one another within elastic limit. So after this point, they're not supposed to be in a direct proportional relationship. So the graph must not be a straight line. So graph can bend. Sometime examiner says continue the graph, and he's very lenient for you. You can bend it anywhere. Like it is not a straight line. So you do this, it is okay. You do this, it is okay. So you have to continue the graph. Make sure that you just change it, that it is not in a straight line anymore. Okay. So this is elastic limit, and we have stretched something beyond elastic limit. What will happen if we come back? Like if we go to this point and we start deloading it. When we deload it, spring comes back. But instead of getting to its original shape and zero extension part, when we remove all the loads, there will be some permanent change. So this is that permanent deformation. This was the graph of loading when we were adding load to the spring, making it stretch more and more and more and more. So this is a loading curve, and this is unloading curve. So when we are unloading, we remove the loads. We gradually go to the point where there is no load. And when there is no load, technically what should happen? There should be no extension. Object should reach its original shape and original size. But here, what is happening? We have removed all the load. Spring has gone back, but it could not go back to its original size. that means we have caused some permanent damage over there. So this is what is meant by permanent damage and elastic limit. And after elastic limit, the force over extension being constant relationship, that is gone as well. The force and extension are not directly proportional anymore after elastic limit. Now, there's not much in your syllabus, like we do not have how different kinds of material behave. So this is all that you need to know about Hooke's law and stretching forces. So we can do some past paper question. It is very hard to find theory question in this topic because the examiner is very uh, reluctant in giving a big question from this topic because there's not much to ask. So normally we see MCQs coming from this question, this topic. But I will try to find some questions so we can do some questions in the next class. Next class will be on Monday. Okay. Thank you very
Okay,
much.
sir.
See you on
Yes.
Monday. Have
See
a
you.
nice weekend.
You too.